Section 6.4, example 6, graphing a stretch or compression of the parent function y is equal to log base b of x. Sketch a graph of f of x is equal to 2 log base 4 of x alongside its parent function. Include key points and asymptotes on the graph. State the domain and range. So here, our parent graph is our graph without any shifts or translations. So it's this graph without this 2 in the front. That would actually be a stretch. So let's go ahead and leave it out for the parent function. P of x is equal to log base 4 of x. And now for our inputs, x, and our output, P of x. Do one more. All right, so here again, it's easiest to use our output or choose our outputs first and then choose our inputs. So choosing our outputs, let's get our normals, so -2 all the way up to +2. So -2, -1, 0, 1, and 2. So starting off with 0 and turning this into a exponential problem, 4 to the power 0 gives us 1. 4 to the power 0 gives us 1. So when we input 1, what do we raise 4 to in order to get 1? We raise it to the power 0. Next, let's try -1. And for -1, we'll have 4 to the power of -1 is equal to, this is going to be 1/4. So when we input 1/4, we output -1 and -2. 4 to the power of -2, that gives us 1/16. So 1/16. And now for 1, 4 to the power 1 gives us 4. So when we input 4, we output 1. Now 2. 4 to the power 2 gives us 16. When we input 16, 4 to what power will give us 16? 4 to the power 2 will give us 16. Let's graph this. Let's shift this over a bit. Okay, because we have to input 16. All right, starting off with the middle. So when we input 1, we get 0. When we input 4, we get 1. And when we input 16, I'm going to do this off camera to make it look a little bit prettier. All right, there we go. Lastly, next, next, when we input 16, we output 2. And we have those. So now let's move on to our fractions. When we input 1/4, we get -1. When we input 1/16, we get -2. So we graph this. And this here is our parent function without any shifts or translations. So no stretches. So here what we're doing is we have our solution here and we're just multiplying our output by 2. So that's what that part means. Let's get that in blue. So here we have our function f of x, 2 times log base 4 of x. And here we have our f of x. So our inputs are going to be the same. So input of 1/16, 1/4, 1, 4, and 16. And our output, we're doubling each of the outputs. So -2 becomes -4, -1 becomes -2. 0 times 0 is still going to be 0. 1 is going to be 2. 2 is going to be 4. So when we input 16, we output 4. When we input 4, we output 2. When we input 1, we output 0. That stays the same. When we input 1/4, we output -2. And when we input 1/16, we output -4. So it doesn't take off quite as quickly, but most of the parts are still the same. Notice that we stretched these points up by a factor of 2, that remained the same. So we just doubled each of our inputs. So our domain, range, and asymptote shouldn't change. So domain, range, and asymptote. Domain, all the values that you could plug in, how to be greater than 0. So here we're still looking at the same thing in our parent function. So going from 0 to infinity. Our range, as always here, from -infinity to infinity. And our asymptote, x equals 0. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.